The topic of today is principle of linear superposition. Let us consider a system and by system we mean a coil or a circuit or an oscillator or any object. And we represent this system by the symbol a boxed S in this way. So represent system as boxed S. Now let us define what we mean by stimuli. Stimuli is something that evokes a reaction or arouses an activity to be done. It might be a force, it might be a torque, it might be a stress, or it might be an applied voltage, it might be an applied electric field, it might also be an applied magnetic field or magnetic induction, and so on and so forth. And let us represent the stimuli as f, which is a function of time t, say. Let us define what we mean by response. Response of system. That is how a system reacts when it is under the influence of a stimuli, which might be a force or torque and so on. And response of the system let us denote by R, and since stimuli or the force is a function of time, its effect, that is the response, will also be a function of time. So if f is a function of time, then R is also a function of time. F is the stimuli, the cause, and R is the response of the system, the effect of the stimuli or the effect of the force. So the response might be if force is applied, that is if a system is pushed linearly, then it will suffer displacement. So displacement is response when stimuli is force. So this displacement is a linear displacement. If a system is acted upon by a stimuli which is a torque, then the response will obviously again be displacement. But now it will be angular displacement. If stimuli is stress, then the response of the system will be strain. If stimuli is voltage, then the response of the system will be current. If stimuli is electric field, then the response which the system exhibits will be showing up of a polarization and under the influence of magnetic induction as stimuli, a system will respond by showing up a magnetization. So these are the response, that is the effect of the stimuli, which are force, torque, stress, voltage, electric field or magnetic induction. So what we have stated just now, let us represent diagrammatically. So this is the system, and a stimuli is acted upon the system. Say force operates on the system, acts on the system. So this is the input, this is the stimuli, and the system reacts or responds, and that response is denoted by R of t, which is obviously the output of the system. Let us now mention what we mean by the principle of linear superposition with reference to this diagram. To describe the principle of linear superposition, we have to study two laws first. One is law of additivity. Let us apply the individual stimuli to the system first. So the individual stimuli are, or the forces are F1 and F2, and they are applied to the system. And the response that we get are R1 for F1, and the response of force F2 or stimuli F2 is R2. And now if these two are added, what we get is the sum of responses R1 and R2. Another way to deal with what we have is to apply all the stimuli at once. That is collective application of stimuli. Which means we add them, and if we add them we get F1 plus F2, and this is fed to the system. Now what would we get? If we get the same R1 plus R2, then our conclusion will be, firstly, this law holds. The law of additivity holds. And the second conclusion will be that the system is linear. And also, principle of linear superposition holds. On the other hand, if we do not get R1 plus R2, then the conclusion will be that this system S is non-linear. It is not linear. So let us write the law of additivity in the form of a statement. sum of responses of system when stimuli are applied separately, as here, separately or individually, is equal to response of system when all stimuli are applied together, that is collectively. And this is the requirement of linearity. This is the requirement for the law to hold. This is the requirement for superposition principle to hold. We now come to the next law, which is law of homogeneity or law of scaling. So here stimuli is applied individually, stimuli individually applied on the system, and the response we get is R. And now we multiply this response by a scaling factor, say K, and then we obviously will get KR. So this is the scaled response. So what we have done is we have scaled the response. We have multiplied the response by a scaling factor, and therefore the response was actually R corresponding to the stimuli F, but we have scaled the response, and therefore we got the scaled response as K into R. And now what we will do is we will scale the stimuli before application to the system. So multiply F by the scaling factor K, and this obviously gives us Kf. And now this is introduced to the system. Now what will the response be? If it so happens that we get the same response, so it is K into R, then what will our conclusion be? Our conclusion will be that the law holds, the law of homogeneity or the law of scaling holds for this system. System is linear. This S standing for the system is a linear system, and superposition principle holds. And if it is not equal to KR, then our conclusion will be that the system S is non-linear. So what will be the statement of law of homogeneity or scaling? So the statement response of individual stimuli. So this is the response of the individual stimuli, which is scaled. Scaled after passing through system is equal to response of stimuli which is scaled before it is applied to the system. So it is response of stimuli, that is the force, scaled before being introduced into the system. And this is the requirement for the law of homogeneity or the law of scaling to hold. This is the requirement for system to be linear. This is the requirement for validity of principle of linear superposition. Let us make a gist of what we did. In other words, let us discuss principle of linear superposition afresh. So in principle of linear superposition, law of additivity should hold, which means individual application of stimuli, say F1, F2, F3, etc., and collective application of stimuli, that is F1 plus F2 plus F3 and so on, produces the same response in the system, same response. So the keywords are individual or separate application, and here the collective application. Whatever may it be, the system responds in the same manner. And then we'll say that law of additivity holds, which in other words is the principle of linear superposition. Principle of linear superposition also implies satisfaction of law of homogeneity or the law of scaling. So law of homogeneity or law of scaling holds, which actually means that scaled response is equal to, as we discussed, response of scaled stimuli. So let me reiterate that principle of superposition means law of additivity holds, law of homogeneity or the law of scaling holds. If principle of linear superposition holds, then the system is linear. And if principle of linear superposition does not hold, then we say that the system is non-linear. So we can write, in a non-linear system, principle of linear superposition does not hold. One thing should be cleared, that both the laws, that is law of additivity and law of homogeneity or scaling, holds for principle of linear superposition to hold. And in fact, if any one does not hold, that means principle of linear superposition does not hold. Let us now write down the principle of linear superposition. In other words, we wish to relate or interrelate f of t and r of t. That is, what will be the mathematical relation, the general mathematical relation or connector between these two quantities. So what is f of t? F of t is the stimulus or the stimuli, and it is the cause, and r of t is the response, the reaction, the effect. Clear that cause occurs first and the effect will follow. Second point is, we have to interrelate them through principle of linear superposition. So f of t and r of t are related linearly. This means they would occur raised to the power 1. So they would occur as f and r and not as f square or r square or in some power. It is raised to the power of unity. And we have to use principle of linear superposition. Note the term superposition, which means sum, but it will be replaced by an integral for continuous application of stimuli. So for continuous disturbance of the system, if we poke the system continuously, disturb the system continuously, system would also react in a continuous fashion. Its response will also be continuous, and therefore sum will not suffice. We have to replace sum by integral. Let t prime be any typical time or instant at which stimuli is f of t prime. T0 is the start of experiment, and the final t is the time at which measurement is done. So t minus t prime is the elapsed time with respect to this typical time. Now let us make a chart. This is the force or the stimuli, and this is the response. So when stimuli is F or force is F, response is R. When stimuli or force is unity, that is unit force, then the response is R by F, and let us call it phi. So this is response per unit force or stimuli, and it is a function obviously of the elapsed time, because the system is responding to the stimulus or force and the response occurs over a time. So elapsed time obviously comes into the picture or comes into discussion. So when force or stimuli is f of t prime, then the response will be this multiplied by f of t prime. So now we are in a position to write down the response. Response is R at time t. So here we should have t, the time of measurement, because we are interested to find the response at time t, up to which we have measured. And measurement is done from t0. So we have here t0, and we have used integration sign so that all the stimuli are taken care of, all the forces are taken care of. So we have to sum over this factor, because this is the response. We have to take care of, we have to sum over or integrate over all the responses. So this is the response, and dt prime will be there, which indicates we are integrating. So this is the required expression. So this is the general form between stimuli and response through the principle of linear superposition. Linear because f to the power 1 up to the power 1, superposition because we have used the integration sign, and this is the response corresponding to this stimuli, and we have to integrate or add over all the responses, and therefore we end up with this expression from t0 to the present time of measurement. Now here one assumption is being done. Assumption made is that the system or the medium does not change, does not age. That is, the characteristics remain same. It retains its behavior or retains its originality. To be very specific, it does not change its elasticity. This is the assumption under which this expression holds. Another point that we can note is, let us write F, let us write R, and F and R are connected by phi. Now what will be the nature of phi? So phi connects F and R. That is one point. Phi is response per unit stimuli or per unit force. Now if stimuli is the electric field, which is a vector, then there will be three components. Then the response, as indicated earlier, will be the polarization, which is also a vector which has three components. And then what will be phi? What will phi be? So three components, so it is 3 into 1. Here three components, so this is also 3 into 1. So this will be or has to be a tensor having 9 components. So it will be second rank tensor having 9 components. Let us give another example. Suppose the stimuli is stress, and stress is a tensor of rank 2 and it has 9 components in 3D space. We are discussing in 3D space. And what will be the response corresponding to stress? It will be strain, which is also a tensor of rank 2. So in 3D space it will have 9 components. Now what will be this one, phi here? It will be another tensor and it will have 81 components of rank 4. And the name of this tensor is compliance tensor. So this is how this phi connects the stimuli and the response.